Hello, welcome. My name is Eugene. I am a lecturer in Kenya. I teach professional courses such as SCCA and CPA. My videos cover various topics found in these professional courses. The main subjects covered are management accounting, performance management, and quantitative analysis. I welcome everyone interested in learning something. Sit back, relax, and let's begin. In this video, I will take you through how to make decisions using Minimax Regret, expected opportunity loss, Laplace Criterion, and Hurwicz Criterion. The following payoff table shows all the possible profit outcomes in dollars. The decision alternatives are the production levels, which are 10,000 units, 15,000 units, and 20,000 units. The uncertain variable is the demand. The demand could be low, moderate, or high. The probabilities for low, moderate, or high demand are 0.2, 0.45, and 0.35. Determining the best production level using the Minimax Regret decision rule. The regret is the potential loss of making the wrong decision. The regret table is prepared. To calculate the regret values, identify the highest profit for each state of demand, which is the uncertain variable. The regret is the difference between the highest profit and the profit for the decision alternative. The highest profit values in each state of demand are as follows. When the demand is low, the highest profit is $45,000. When the demand is moderate, the highest profit value is $67,500, and when the demand is high, the highest profit is $90,000. The regret table is as follows. When the demand is low, we've identified that the highest profit is $45,000. In the row for the low demand, we take 45,000 minus the profit under each production level to calculate the regret values. When the demand is moderate, we've identified that the highest profit is $67,500. Therefore, in the row for the moderate demand, we take $67,500 and subtract the profit under each production level to get the regret values. When the demand is high, we identified that the highest profit is $90,000. Therefore, in the row for the high demand, we take $90,000 minus the profit under each production level to calculate the regret values. To determine the best production level using Minimax Regret decision rule, we identify the maximum regret for each production level. For 10,000 units, the maximum regret is $45,000. For 15,000 units, the maximum regret is $22,500. And for 20,000 units, the maximum regret is $35,000. The best production level will be the one that has the lowest value amongst the maximum regret values. In this case, the lowest maximum regret value is $22,500. Therefore, the best production level is 15,000 units. Determining the best production level using the expected opportunity loss. The expected opportunity loss is calculated by using the formula sum of x times p, where x is the regret or opportunity cost and p is the probability. The decision rule is to select the decision alternative which minimizes the expected opportunity loss. Using the regret values from the regret table and the probabilities for the different states of demand, the expected opportunity loss is calculated as follows. The expected opportunity loss for 10,000 units is $25,875. For 15,000 units, $11,375. And for 20,000 units, the expected opportunity loss is $14,875. The best production level will have the lowest expected opportunity loss. The lowest expected opportunity loss is $11,375. Therefore, the best production level is 15,000 units. Determining the best production level using the Laplace criterion. All the possible outcomes are assigned equal probabilities. Each decision alternative has 3 possible outcomes. The total probability is 1, hence each outcome is assigned a probability of 1/3. We calculate the expected monetary value using the formula sum of x times p, where x is the profit and p is the probability. Using the profit values from the payoff table and the equal probabilities of 1/3, the expected monetary values are as follows. For 10,000 units, the expected monetary value is $45,000. For 15,000 units, the expected monetary value is $54,167. And for 20,000 units, the expected monetary value is $50,000. The payoff is profit. Therefore, the best production level will have the highest expected monetary value. In this case, the highest expected monetary value is $54,167, which means that the best production level is 15,000 units. Determining the best production level using the Hurwicz criterion. For each decision alternative, use the best payoff and worst payoff to calculate the weighted average payoff. The weighted average payoff is calculated using the formula alpha times best payoff plus 1 minus alpha times worst payoff. Let the coefficient of optimism alpha be 0.3, then the coefficient of pessimism 1 minus alpha will be 0.7. The weighted average payoffs are calculated as follows. From the payoff table, all the profit values for 10,000 units were $45,000. Therefore, the best and worst payoffs are $45,000. For 15,000 units, the highest profit was $67,500 and the lowest profit was $27,500. For 20,000 units, the highest profit was $90,000 and the lowest profit was $10,000. Using those values, the weighted average payoffs are $45,000, $39,500, and $34,000. The best production level will have the highest weighted average payoff since the payoff is profit. In this case, the best production level is 10,000 units with the highest weighted average payoff of $45,000.